right? And that is what we're going to hope to do there. So we're starting from scratch with what is mathematics? Math or mathematics, math for short, is a language, and it's just like any other language. Now I have here, and what I have here is is the language of science, Bagan and Cross of science. No, maths is the language of everything. Everything that exists in the entire universe, right? So maths is a language. It is the language of everything. Everything that exists, right, is the language. And like any other language, like the English language, like in the English language, we have nouns. Nouns are things. And then we also have verbs, and verbs are what you do with those things. So we have two things we have more than two things, in language. We have things like adjectives and all of them kind of thing too, right? So we're going to talk about that. Now, Sarah, I might ask you that one, but in terms of language, right? Maths is a language. And in a language, we're supposed to have nouns, which represent things. And we're supposed to have verbs, which represent what we do with those things, right? So the things in maths are the numbers. The numbers, and we have many different types of numbers. You have numbers like this. You have numbers like this. The familiar numbers that we know. You also have numbers like this, negative numbers, right? We also have numbers like this, negative fractions. We also have numbers like this, which are irrational numbers, you just call it. We even have unknown numbers. When you have unknown numbers, you write it like a letter. Yeah, that is what algebra is. Algebra is just an unknown number. Right? So you can see we have many different types of things in maths, and we're going to go through all of these things. And what do we do with those things? So what are the verbs in maths? What do you think is the verbs in maths, Mashaila?
So the operations, addition, subtraction,
Right.
division, multiplication.
Yes, so the verbs are what we do, to do. And we only do a couple of things in maths, right? We do these things. We multiply, we divide, we add, and we subtract. So these are what we do, right? Sarah, how many verbs are there in the English language? Kimberly, how many verbs do you think there are in the English language?
About 1,000 or 500 something. I don't know.
It only have
Is that
one.
bigger?
It only,
Yes.
but it only have one.
Always one, sir.
Well, you know that we have verbs like to
Always.
jump, and we have verbs like to walk, and we have verbs like to sing, and we have verbs like to eat, and we have verbs like to sleep. But all of these infinite verbs you have in the English language does just boil down to one verb, and that is the only verb, to do. To do is the only verb in the English language. It don't matter what you're doing, whether you're jumping, you're walking, you're singing, all of them is just one verb, to do. Yeah. And in maths, it's pretty similar, because in maths we have these four verbs. These are the things that we do, right? We add, we subtract, we multiply, we divide. So you're thinking, yes, four things you just do in maths, but guess what? Addition and subtraction. Subtraction is just addition in the other direction. So addition and subtraction are pretty much the same thing. Multiplication and division. Multiplication is just repeated addition. And so when you really boil it down, addition is the only thing we just do in maths, Because think about it. If you multiply in 2 times 3, what you're actually doing is you are adding 2 3 times. That's what you're actually doing. Yeah. So all of this might seem like, like it might make your brain hot a little bit, but hopefully as we go deeper down, you could understand these basic things, right? But we also have adjectives, and in language, we also have an adjective, which is words that we use to describe things. Sarah, what do you think the adjectives are in maths?
So like equal
Yes.
and like
Equal is a description, is an adjective. It's saying that this is the same as this. Yeah. So we have many adjectives in maths. We have equal, and when you have three strokes, we have equivalent to, right? You don't have to remember it. Don't worry. We'll write it down later on. We have things like less than or greater than or less than or equal to, greater than or equal to. So we have adjectives, and we could put all of these things together to give us a sentence. And that sentence is saying that if Amaya have 3 mango and Kayla Cox have 2 mango, then the two of them together have 5 mangoes. So this is an entire paragraph. So mathematics is the most efficient language there is, right? Any questions? So you could see here we are talking about directed numbers, and this should be familiar to you, right? You see in here what we're talking about is a number line. And in the middle of the number line, we have the 0. And getting greater than 0 is going in this direction. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And this arrow goes to show that we go to positive infinity. So these are the positive numbers. They automatically have a plus sign in front of them, but you don't have to write the plus sign. They are positive numbers. You could think about them as being happy numbers, yes? But you can notice that when we are going in this direction, we are getting bigger, right? So we add in. When you add in, you just be going in this direction on the number line. So 3 plus 1 is 4, plus 1 is 5, When you are subtracting, you're going back this way. So you see what I was saying now about subtraction is just addition in the other direction, right? So if you take 5 and you minus 1, you'll get 4. You minus 1, you get 3. You minus 1, you get 2. You minus 1, you get 1. You minus 1, you get 0. Minus 1, minus 2, minus 3. So you can see that when we go in this direction, we are getting smaller and smaller. And even when we pass 0 and go into negative numbers, right? These negative numbers here, you might see negative 8 as being, well, 8, 8 bigger than 4, right? So you might think 8 might be bigger than 4, but no, this is negative 8. Right? So the bigger the negative number is, the smaller the quantity is, because when we go in this way on the number line, we are getting smaller and smaller, right? So you can see on this side of the number line, on this side of the 0 is where we have our negative numbers going all the way down to the very smallest negative infinity. Yeah, we're getting smaller, even smaller than 0. You might want to know how that is possible, right? How is it possible to have a number less than 0, right? I mean, I understand I could have 3 mangoes. I could have 2 mangoes. I could have 1 mango. I could have 0 mangoes. But how is it possible for me to have minus 1 mango? How is it possible for me to have minus 5 mangoes? Yeah, so what you could think about this as when you're owing to O, right? To O, right? And we have something called the O, which is minus, and the P, which is plus, right? So imagine I have minus 1 mangoes. That means that I owe in Kayla 1 mango. Yeah. And so even when I get a mango in my hand, it's still not mine. I had to give Kayla it. And then I go have 0 mangoes. Yeah, right? So you could think about it as O and P, right? O being minus, and this will actually help you when we are doing these questions here. Now, I want everybody, and I'm going to give you 1 minute. Everybody use this number line to answer these questions, and I'll do a couple of them for you, right? I'll do these first 2 here for you, right? So check it out. 1 plus 3. Well, you know, when you're plussing, you're going in this direction. So I'm starting with 1, and I'm going to add 3. So this is 1 plus 3. So I add in 1, 2, and 3, and you see I end up here. So 1 plus 3 is 4, right? So then we just do basic baby thing we doing on the number line here. I'll do the second question. Negative 2 plus 5. Negative 2 plus 5. Well, I'm starting with negative 2 here. And then I'm going to add 5. So adding means I'm going in this direction. So I'm going to add 5. 1, 2, 3, 4, 5. Right? So you can see negative 2 plus 5 is 3. Yeah? And so I will allow you guys 1 minute to use the number line and see if you could finish out 1, 2, 3, 4 questions. 1 minute. All right. So with 4 minus 5, we're gonna use the number line, right? So you know we on 4. So I have 4. So 4 is this one here. And this is 4 over here. You're cool with that? Right. And when we minus in 5, to minus means we going back in this direction. You're cool with that? All right. So from 4, we minus in 5. 1, 2, 3, 4, 5. You seeing that? So the answer is negative 1. You seeing that, right?
Yeah.
Now, this is the number line way of thinking about it. But just now, I will do over these questions using this way of thinking about it. And today, we're going to be doing some rules that we had to know. But this is just number line stuff we're talking about here, right? Not 5 negative. No. Stop thinking so much. Stop thinking so much. Yeah. 5 minus 4, ain't?
Yes.
And 5 minus 4 is 1, right? So you see how you was overthinking, yeah? Because you're in a maths class, you feel you had to put your brain on overdrive. No, you don't. This is gonna be easy, right? And imagine on the number line we have 5, and your minus 4 means you're going in this direction. 1, 2, 3, 4, and you end up on 1. Right? So we're doing it the number line way, and just now I'm gonna show you the O and P way, right? Oh, good. What about this one?
Negative 5, sir.
All right, Amaya cooking with Ramco gas. All right, and negative 2 is where we start, and then we see and we minus in 3. So we had to go in this direction. 1, 2, 3, and we are on negative 5. So this is why we call it directed numbers. Yeah. So you can see here we end up with negative 5. Right? And what about this piece of madness here? Right? Well, you know what? I'm going to scrap this piece of madness for now, but we are going to come back to it. You're going to meet a question like this, and you're not always going to have a number line draw out, especially if you have bigger numbers, right? So imagine this, a positive number, and you have a negative number, right? So you can see here 1 is positive. So you're paying $1, right? You're paying $3. So if you had to pay Tech $1, and then you had to come back and pay them $3, you're gonna have to pay them $4, right? Actually, no. Let me change that. If Tech had to pay you $1, so they pay you getting paid here $1, they charge you too much for electricity now, so they had to pay you back. So they're paying you back $1, and then they come back next week and they pay you back $3. Well, it's $4. Right? But you could see here that the minus means O. So imagine you owe $2, right? And you pay $5, right? So I owe Kayla $2, but I have $5. So if I owe Kayla $2 and I have $5, well, I could just give she $2 and I go have $3 left. Yeah. In this case, sorry. Right. In this case here, all right, I have $4, but I owe him $5. So imagine I owe Tony $5 and I only have $4 to my name, but I owe Tony $5. So I had to give Tony the $4 I have, and I had to cry because I had no more money. But I still owing Tony $1. Yeah, I still owing $1. Right? So you can see how the owe and pay, every time you see a minus in front of a number, that is how much you owe, and anytime you see a positive number, that is how much you have, right? So in this example here, you can see I have $5 and I owe Karen $4. So when I pay Karen she $4, I gonna have $1 left. In this case here, I owe Karen $2, but then I come back and I owe she a next $3. So I owe $5. Right? Now, this might seem confusing to some of you all. It have many ways to think about it. And if this is confusing to you in any way, just now we will write down some rules, and the rules will clear it up. And remember, take good notes, Take good notes. Right. So you see here, we have something called signs, and we have something called operations, right? Because I could have, and I'll just put a little working column here with a little example, right? I could have a number, a negative number, say -3. That number is not doing anything. It not adding, it don't have no other numbers next to it. It not adding anything. It have a negative here, yeah, but it not subtracting from anything. It don't have any other numbers around. So that -3 just liming with his sad self. Yeah, because, negative numbers are sad numbers. They're kind of sad now. They're small, So this 3 isn't doing anything, right? Remember, to do is a verb, to add, subtract, multiply, or divide. Yeah, but this 3 is not doing anything. So this negative is not a subtraction because it's not subtracting from anything. So that means that negative refers to a sign. If a number is happy, it's positive, or if it's sad, it's negative. This is the sign of the number. The number not necessarily doing anything. It's just by itself, but it have a sign, happy or sad. Right? The sign can show it is positive or negative, and that negative should be in our little brackets here, right? So for example, you can see that I have a +3, right? So that's a happy 3, right? Or I could also just write the 3 by itself. Notice I put an equal sign here. That means, and you must know this, if you see a number written by itself, that is automatically positive. Yeah, it's automatically a positive number, right? Or I could have a negative number written here. So this is a sign. A sign is positive or negative. You notice it had nothing to do with multiply and divide here. This is a sign. A sign could either be positive or negative. This is not add and subtract. No, this is just telling you where it is on the number line. Because if you had a number line and this is 0, +3 go be over here and -3 go be over here. So the sign is just telling you where it is on the number line. Is it a happy number or a sad number, right? The operation is what we are actually doing. So the operation refers to what a number is doing. So in this case, I have 1 minus 3. Yes, the sign of the 3 in this case is a negative. Yes. So the sign of the 1 here is a positive 1. Right? It have nothing in front of it. The sign is usually written in front of the number. If it have nothing written in front, it's a positive. And you can see this one is a negative. So the two numbers have the signs, but they are subtracting from each other. Yeah, they're subtracting 1 minus 3. So in this case, the minus is not only a sign. It is a sign that the 3 is negative, yes. But it's not only a sign, it's also an operation. That means that these two are doing something. They are subtracting, or they're adding, or they're multiplying. And I have these two examples here. You can see I have 2 multiply by negative 3. And how, if you don't know how to do this multiply, don't worry, we'll talk about it just now, right? But you can see here that I have a sad number. So this number, the sign of the number is a negative. But the number is not subtracting, it's multiplying. This is what the number is doing. Yeah. And as I say, we do have some rules coming up that will clarify everything for you. Right? In this case here, you can see we have minus 3x. Remember, x is an unknown number. Right? And, you know, this is more algebra. So the people, the new students who never did algebra before, this might seem a little bit confusing to you. But that is okay. You'll get it eventually when we do algebra soon. Right? But this actually means multiply. When you write numbers together like that, it means you're multiplying. And we will see that very soon. To hear that, right? Amaya, where's 3 plus 4?
7, sir.
Right. Amaya, where's 4 plus 3?
7.
Right. So you could see here, addition is commutative. This is a big word. It's a big word in mathematics too. Right? That means that I could switch the place of the numbers and I'll still get the same answer. Right? So that means that 3 plus 4 is the same as 4 plus 3. You see how we write in sentences now, right? Or in algebra, when we use an algebra, we use letters. Letters, this just represent unknown numbers. Letters are numbers. It don't have any letters in maths. It's only numbers. Numbers are the nouns. So you can see here any number, x plus y will be equal to y plus x. Mashaila, since you're on the microphone, what is 4 minus 3? Don't think too hard.
1.
All right. But look, we switch the numbers here. Where's 3 minus 4, Mashaila?
Negative 1.
Negative 1. Remember, if I owe Karen $4 and I only have $3, well, I could give she the $3, but I could still be owing she $1. Yeah. So you could see here that subtraction is not commutative, because if we switch the numbers, you put the 3 here and you put the 4 here. If you switch the numbers, you do not get the same answer. So therefore, 4 minus 3 is not the same as 3 minus 4. These are two very different things. And we could generalize it by saying A minus B is not the same as B minus A. Right. Now check it out. Subtraction is not commutative, right? So if I have 4 minus 3, and I put the 3 on this side and I put the 4 on this side, but I leave the subtraction in the middle, right? So we have 3, I leave the subtraction in the middle, and I put 4. Well, these are not equal. But I could shift things around if I wanted to. Yeah? If I wanted to, instead of shifting it around and leaving the subtraction in the middle, you know why they're not the same? Look at this question here. 3 is a sad number in this question. But look at this question here. Over here, 3 is a happy number. No, we can't have that. 3 is supposed to be a sad number. Yeah. So when we flip it, 3 becomes happy. So it's a different question altogether. They can't be equal. They can't be equal. Look, in this question, 4 is happy, but in this, on this side, 4 is sad. So there's no way that they could be equal. No, they're not equal. But I could shift the numbers around. What if I say 4 minus 3, right, is equal to, instead of taking the 3 and putting it on this side, I will take the entire minus 3, because 3 is a sad number. So I will make sure that 3 remains sad, right? So I will put the minus 3 first. And that means I'm going to take this 4 and put it on this side, right? So you could move numbers around as long as you keep the sign. Remember, on this side, the 4 is a plus. So if I move the 4 on the other side, it will become plus 4. Yeah, that plus was always there. We just didn't need to write it. Yeah, so I could flip the numbers around, and yes, these two will be equal, right? You could see the 3 is sad on this side, and the 3 is also sad on this side, right? The 4 is happy on this side, and the 4 is also happy on this side. So these two are actually the same. So we could take numbers and move them around as long as we keep the sign. This is called the associative law. So with the associative law, we could add or subtract in any order as long as we keep the sign. So we could move numbers around and shift it around. So for example, 4 minus 3 is 1. Everybody should know that. Yeah. But I just take the minus 3 and I put it on this side. And I take this plus 4 and I put it on this side. Well, guess what? This is the same question. Yeah. This is the same question. So in this case here, you could see I owing Karen $3, but I have $4. So I could pay she back the $3 and I will still have $1 left. You see, we get the same answer, right? Over here, I owing Kimberly $4, but I only have $3. So by the time I pay off Kimberly, you know, before she sent people with cutlass and things from it, I'll pay she off the $3, right? But I'll still have $1 for her. I'll still owe her $1, right? Look, I could take this minus 4 and I could put it on this side. I could take this plus 3 and I could put it on this side. We can rearrange the numbers. We can add or subtract. We can rearrange, right, numbers in any order as long as we keep the sign. So we could take numbers and move them across and move them so and so and so and mix them up as long as the happy numbers remain happy and the sad numbers remain sad. Right, so these are the rules here. And you must know these rules. There's about 4 of them. So you can see we starting with the rules for addition and subtraction. And this is when you're dealing with 2 numbers or groups of 2 numbers, right? You take a look at the signs. Rule number 1, if the signs are the same, right? And Tony, just know these rules and you'll be good to go, right? So you're looking at this example here, 3 plus 4. Well, you know that this is a plus 3. It have no minus in front of it, so it have to be a plus 3. And this 4 have the plus in front of it. So therefore, the signs are the same. Yeah. When the signs are the same, all you had to do is add the numbers and keep the sign. So 3 and 4, the two of them, the signs are the same. So I will add the numbers. There'll be 7. And I will keep the sign as a plus. But you don't have to put the plus. The plus is understood. Right? Look at this example here. When the signs are the same, so we have a minus 3 and then a minus 4. So they both are negative. They're both sad. So when the signs are the same, you add the numbers. So 3 and 4 is 7, and you keep the sign. So the sign there is negative. It will be -7. And I have 4 of them. You see, I have 4 questions here. You all have 30 seconds to do these questions, and then I'm asking answers. Right? Questions, when the signs are the same, so you can see this is a -3 and a -10. The signs are the same. So 10 and 3 is 13. You just add them and you keep the sign, -13. You can see here 2 plus 14. The signs are the same, so you add them, 14, 15, 16. And you keep the sign. The sign is positive, so I don't need to put anything there. Over here we have -2 minus 3, and that is a 3. Sorry for writing it like that. When the signs are the same, you add them. So 3 and 2 is 5, and you keep the sign. Over here, 8 and 8 is 16. 8 and 7 will be 15, so you add them and you keep the sign. And so those are the rules for addition and subtraction when the signs are the same. These are the rules for if the signs are the same. But what if the signs are not the same? What if the signs are different? So rules for addition and subtraction. Please write your notes. If the signs are different, right? What you're going to do, and I'm rubbing off these answers here, is you're going to find the difference. So check it out. I have 4 minus 3, right? Well, the 4 is a positive 4, and the 3 is a -3, so the signs are different. So when the signs are different, I'll find the difference. So the difference between 4 and 3 is 1. But then, which sign do I keep, though? Do I keep the negative sign or do I keep the positive sign? Well, you keep the sign of the larger number. So in this case, 4 is the larger number, so I will keep the sign of the 4. I should say the larger digit, really, but I'll keep the sign of the 4, so it's a positive, right? In this case here, I could see the signs are different. Right? The 4 have a negative, the 3 is positive, so the signs are different. If the signs are different, you find the difference. So the difference between 4 and 3, Tony, is 1. But then which sign do I keep? Do I keep the positive or the negative sign? Well, I'll keep the sign of the larger number. So 4 is the bigger number here, so I will keep the negative. So anyways, I only have 4 questions here. Let me hear done it when you're done it. Now, let me get this first one here. And feel free to be wrong, Kimberly. It's no problem if you're wrong.
The answer is 1.
Yes. Oh, so you didn't want to answer it because it's the easiest one. Kayla Tobago. Where's this one? Yes.
-5.
Careful. So Kayla Tobago, the signs are the same or the signs are different?
Different.
So when the signs are different, you have to find the difference, right? So where's the difference between 3 and 2?
-1.
Ah, careful. I didn't ask you about the sign. I just asked you what's the difference between 3 and 2. What's the difference between 3 and 2? The difference between 3 and 2 is 1, and?
Yes.
Right. And then which sign do you keep? You keep the sign of the larger number. So which is the larger number, 3 or 2?
3.
So it'll be positive 1. You seeing that, Kayla? Right. So let me ask you something. Are the signs the same or are they different?
They are the same.
They're the same, right? Well, are they the same though? Because you're seeing I'm seeing a negative in front of the 5, and I'm not seeing nothing in front of the 4.
No, it's not nothing.
All right. So that means that the 4 is a positive, and
Yeah.
so that means that the signs are different, right?
Yeah, but you have to take the negative from the 5.
Right. So, all right. So if the signs are different, you're fine. We're taking it one step at a time. Ah, you see where you went wrong there?
Yeah.
Yeah. So if the signs are different, what's the difference? We have to find the difference. What is the difference between 4 and 5?
It's 1.
Right, 1. And we had to keep the sign of the larger number, which is the 5, and so the answer is negative 1. You understand?
Yeah.
Right. Yeah. Right. Now, guys, the reason why you should have no problems being wrong, well, I'll tell you that after. I'll tell you that after, right? Let me see this last one. Brianna, you there? Give me this last one.
Negative 8.
Negative 8 like a boss. You can see the signs are different. So the difference between 10 and 2 is 8. And keep the sign of the larger number. Anybody still writing? These are just the rules for addition and subtraction. What about multiplication and division? We had to talk about that. Right? But first, we're talking about this. We're talking a little bit more about the associative law here. Remember, the associative law is saying that I could rearrange numbers as long as I keep the sign, right? So I could take this this here and I could rearrange it to say negative 3 plus 4. I could rearrange it as long as I keep the sign. So the 3 is a sad 3 and the 4 is a happy 4. So they'll both be the same. This is incredibly useful when it comes to helping us add in long strings of numbers. So you could see that I have negative 2 and I have a negative 5. So that is minus 2 minus 5. I have a plus 3 and a plus 4. It's the same question. Nothing changed here. I just rearranged the numbers, but I keep the sign. Now I could see that here, these two numbers, the sign is the same. Yeah, so these two numbers, the sign is the same, so I could add them. 5 and 2 is 7, and I could keep the sign. Yeah, these two numbers here, the signs are the same, so I could add them. 4 and 3 is 7, and I could keep the sign. These two here, the signs are different, right? So I could say, well, you know, when the signs are different, you find the difference. The difference between 7 and 7 is 0, right? This is really just 7 minus 7, you know. You would think that 7 minus 7 is 0, but remember, with the associative law, I could take the minus 7 and put it there, and I could take the plus 7 and put it there. Now, the associative law helps us in other ways. It helps us to, you know, just do things quickly, right? So take this question here, for example. The normal person would want to say, okay, minus 4 plus 3 is minus 1. And then minus 1 minus 2 is minus 3. And you're going down the line and you're busting your brain. But the associative law helps you with that. Right? The associative law says, look, I have a minus 2 here. And I have a plus 2 here. And 2 minus 2 is 0, right? So that means these two is going to cancel. Look, I have a plus 3 here. And I have a minus 3 here. Well, 3 minus 3 is 0. So these 3's cancel in here. And you can see here, I have a plus 4 and I have a minus 4. Well, 4 minus 4 is 0. So these 4's cancel here. So the answer for this question is 0. But this is just another way of using the associative law in recognizing that numbers could cancel with each other. Right? For example, in this question here, I see that minus 3 minus 4. I could put the minus 3 and the minus 4 and the plus 7. So nothing can cancel here. 3 can't cancel with 7, can't cancel with 4. No, nothing can cancel here yet. So I would group them. Minus 3 minus 4. You can see that minus 3 minus 4, Tony, the signs are the same. So you would add them and keep the sign. So you have minus 7 and then you have plus 7. Well, minus 7 plus 7 is 0. Kimberly, what is 2 plus 3?
5C.
So these two numbers add together will give you 5, and?
Yes, sir.
And you're seeing, where's 5 minus 5?
0.
So that means that this 5 here gonna cancel with this 5 here, and?
Yeah.
So what do we have left?
A minus 4.
That is all. Right, like a boss. That's what I'm talking about, right? So I take the 2 plus 3, and so I have minus 5, and this 2 plus 3 give me plus 5, and then I have the minus 4. And well, the minus 5 plus 5, that gone, so I will just have minus 4. Subtracting a negative. Yeah, we have a very special case here. You can see we have 2 minus, and then in brackets you have minus 3. Right? So the brackets are really doing nothing. When you pull out the brackets, you just end up get 2 minus minus 3. And I believe, Kimberly, this is what you was talking about. Right? I have no time for Stanley right now. Right? And in this case here, just now, I'm on.
Yes, sir, because in my head, this keep popping up.
Yes, well, this is what you was talking about. When you have these two minuses together, they do form a plus. Can anybody, and especially my older students, Sarah, take a break from physics for a minute day, right? Sarah, you know a minus and a minus is a plus, right?
Yes, sir.
Can you tell me why? The answer is right here on the screen. Subtraction is also known as the additive inverse. This is just why. So yeah, you could learn the rule that when you see two minuses together like that, a minus and a minus is a plus. That's just a rule you had to know. But I want my students to know why. Because everybody knows the rule, but nobody knows why. And why is because subtraction is also known as the additive inverse, right? So remember, plus, just go in this way on the number line until you bounce up a minus. When you bounce up a minus, you had to go back this way, right? So you notice what a subtraction does. It changes the direction that you go in. All the time you go in your happy way along a very plus and positive life, and then a negative person come in your life and set you back. I'm sure that happened to you already. Yeah? So the thing is that subtraction is the additive inverse, which means to do the opposite of whatever came before. That is what it means. That is what subtraction means. Do the opposite of what came before. So we have a minus 2 here. Well, it don't really matter what number this is, but we go into minus, right? So when we go into minus, that means we're supposed to be going in this direction, right? But then we minus in another minus. So this says, hey, no, don't go in this direction, turn around and go back so. Yeah, do the opposite of what you was going to do before. So what I was going to do here, I was going to go in this direction. So now this one telling me, no, do the opposite, turn around and go back so. Yeah, and that is why, because subtraction basically means go in the opposite direction from addition. right? It is called the additive inverse, is another word for subtraction. Write this down. Let me get some done it. You know you're getting some questions just now. Right, so we're going on. Oh, well, oh my, look at what I have here. 19 questions. Well, it's not 19 questions, but it's a certain amount of questions. Get what? You're going to get 5 minutes or less than 5 minutes. Less than. Once you know your rules, you could do this. You could do this going down the place, right? You see them brackets, don't fret them brackets. Just remove the brackets and you're going to be good to go, right? But just keep the signs though. Keep the signs, right? So you're taking 3 minutes here. Say done it when you're done it. I just kind of cut this half out. Right, so let me talk number one. Right, we have 1 minus 3. When the signs are different, because this is a plus 1, it have no minus in front of it. So this is a plus 1. So the signs are different. So I find the difference and keep the sign of the larger number, which is the 3. You could see here, we go into number 3, which is brackets -6 minus brackets -8. And I told you that in this case, you could just remove the brackets and nothing wouldn't happen. Just keep all the signs though, right? So you could have -6 minus -8. Tony, tell me if you understand that. You understand that?
Yes, sir.
All right. Yeah. And you can see I have these 2 negatives here. So that them 2 negatives will turn into a plus. So it turns into -6 plus 8. And when the signs are different, one is minus, one is plus, you find the difference, 2, and you keep the sign of the larger number. So the answer there is 2. The larger number being plus 8. This is just 8 minus 6. That's all that is. All right. Number 5, we have -3 in brackets, -3. And I told you in this case that you could remove the brackets. So you'll just have -3, -3. And that will give you, well, the signs are the same. So when the signs are the same, you add them. 3 and 3 is 6, and you keep the sign. All right. We have 3 minus, and then we have a -5 in brackets. Well, I told you to just remove the brackets, so that is 3 minus -5. When the signs, well, when we have 2 minuses, you just get a plus. And so the answer there is 8. For number 9, we have -7 in brackets, minus -5. And I told you just remove the brackets. So we have -7 minus -5. You know these 2 minuses gonna give you a plus, so that is -7 plus 5. And when the signs are different, you find the difference and keep the sign of the larger number. Just remember that when the signs are different, you find the difference. Number 11, you have 3 minus brackets -1. Well, just remove the brackets. 3 minus -1. That gives us 3 plus 1, which is 4. Number 13, 6 minus 3. Well, if the signs are different, you find the difference and you keep the sign of the larger number, which is 6. So 6 minus 3 is 3. So you see these rules does work for normal addition that you already know how to do. The rules still work, right? Number 15. I'll just remove the brackets one time. So you have negative 5 plus 3. Why is it so fat? I don't know. All right. When the signs are different, you find the difference, which is 2, and you keep the sign of the larger number. We have number 17, 2 minus 3. When the signs are different, the 2 is a plus, even though the plus is not there, it's a positive. So when the signs are different, you find the difference. The difference between 2 and 3 is 1, and you keep the sign of the larger number. Just follow your rules. Just know your rules, right? Number 19 here. Minus 8 minus 5. That gives us negative 8 plus 5, which gives us, when the signs are different, you find the difference, keep the sign of the larger number, which is 8. This, we needed to move on today to multiplication, right, and division, and the rules for multiplication and division. So this is where we'll pick up in the next class, the rules for multiplication and division, right? And then we had to move on to, multiplication and division when the signs are the same, when the signs are different, what to do, right? So we're talking about multiplication and division next class. We're also going to talk about BODMAS in the next class, right?